Hello everyone, welcome to OdinSchool. Today in this class, we are going to learn about the last piece of advanced statistics, which is learning about hypothesis testing and what are the different types of tests that we can do in under hypothesis: Z-test, T-test, F-test, and most importantly, we are going to learn about the errors that can possibly occur when we will be dealing with hypothesis testing. Before getting into the content, let me quickly ask the most important question: why should someone learn statistics? Statistics is one of the most widely used skill or a subject in both professional as well as in personal life. If you take your personal life, every day we make a lot of small and big decisions. All the decisions are generally quantifiable in nature. Say, for an example, I wanted to reach my office around 12 a.m., 12 p.m., but I have my office and my house is 10 kilometers far from each other, and the traffic in between them is a little high during 11 a.m. Or the route that I'm picking is a little longer than the original route. So there are several factors that we will consider even to go for the office. Even if you're going for college, you'll have to calculate what is the best bus route or what is the best travel route you can take, which will save you money, time, and energy. So even the slightest of the decisions in real time involves numbers. All these calculations happens through you with in the form of max, which is actually supported by statistical measures. Very few familiar statistical measures are average, median, mode, standard deviation, variance, percentage, percentile. All these things are statistical measures only. So we will use them in both personal as well as in professional life. If you take business, in a business, if I wanted to understand how well my business has performed in the last month, or how well am I performing in the next month, what will be my prediction, and what is the improvement area, where am I lacking in terms of business, where am I doing good, who are the sales representatives or employees, to whom should I give commission. So everything can be given an answer only if we allow statistics to be involved with the data and generate an output. That is the idea behind statistics. Hence, learning statistics is vital in both personal and professional lives. Let me quickly introduce about OdinSchool and about me as well. OdinSchool is a technology upskilling platform. They help us continuously acquire new skills. Their motto is to stay skilled and stay ahead. About me, I am Gautam Kumar Jayachandran. I have 6+ years of experience as a senior data scientist. I've worked in several technologies like Excel, SQL, Python, Tableau, machine learning, and analytics. I currently work with financial domain. Now let's quickly understand what is our agenda for today. First, we are going to learn what is hypothesis testing. Then we will move on to different types of tests in hypothesis: Z test, T test, and F test. Then we will finally move into the error understanding. What are the different types of error that can possibly occur in hypothesis testing, and what will be the impact if a particular error happens. With that said, first let's understand what is hypothesis. Before going into the theory portion, let me quickly give you a use case. Hypothesis is simply nothing but if someone wants to, if someone is saying some statement, some prediction. Suppose I'm saying today in the match, India will win against Australia. Anyone can say anything, but how do I validate the statement said by someone and generate an output and go with a particular statement? To validate any prediction, to validate any assumption, we will go with hypothesis testing. Hypothesis testing is all about validating an assumption and telling whether this assumption is true or not. How do we do it? With the help of statistical significance. Suppose I'm saying India is going to win against Australia. What should I do? It has to be quantifiable in nature. I will have to consider the last 10 or 15 matches for our India versus Australia, and then see what is the majority of what is the win percentage of both India and Australia. If the majority of the wins were India in the last 10-15 matches, then there are good chances that the statement that I said is going to be true. However, if Australia seems to be the majorly winning side, then it is the statement that I said will be in question. So if I wanted to calculate whether the statement is right or not, what we will do is we will simply calculate the mean value between both the teams and see whether there is any statistical significance or not. With that, if there is statistical significance, I will say yes, my statement is true. If I don't have any statistical significance, I'll say no, there is no difference, there are no chances, or there are very less chances that India might win today in the game. Just an understanding, we will see a lot of examples with data. Let's first see what is hypothesis theoretically. Statistical hypothesis, or just a hypothesis, is an assumption of a few population parameters. Hypothesis testing is a procedure whereby we arrange to reject or fail to reject a hypothesis. So someone believes in something and someone else is saying, someone is believing that India will win, but someone else is coming and saying, no, no, India will not win today, Australia will win today. Now, how do we quantify or validate the existing belief that I am having? What is my existing belief? My existing belief is that India will win, but someone is coming and saying an alternative statement. You're saying that no, no, Australia will win. Now we have to validate these two statements and see which statement is true, which statement is false. In this case, the existing belief is basically null hypothesis. When I say existing belief, it is already the proven fact, already the general belief that we have as human beings in terms of business as well as professional life. This can be the hypothesis under investigation or the statement being tested. The null hypothesis may be a statement that is there is not any effect, there is not any difference, or there is not any change. The possible outcomes in testing a null hypothesis are reject or fail to reject. So basically, the idea is we already have some notion, we already have some belief, or we already know some fact. Since someone is giving an alternative statement or an opposing statement to it, we will try to reject the existing belief. Now, why do scientists conduct experiments, keep on conducting experiments? Now, what they wanted to do is they wanted to identify something new and prove the old belief or the old thing that we have is wrong. Now, someone says drinking coffee is injurious to health, but scientists keep on conducting experiment to prove no, no, coffee drinking is not harmful. So what is the agenda of the experiment? The agenda of the experiment is to reject or disapprove the existing belief. The existing belief is that drinking too much of coffee is bad for health. Now someone is conducting several experiments to identify whether coffee drinking is injurious to health or not. It is basically the idea to reject the existing or disapprove the existing belief. Various alternate hypothesis is the purpose of the experiment. Why do we conduct the experiment? We will come up and say no, no, coffee drinking is not injurious to health. Various null hypothesis is coffee drinking is injurious to health. So in alternate hypothesis, theoretically, this is often a press release you will adapt if there is a strong evidence against the null hypothesis. So against my existing belief, if you provide evidence, I'm eventually going to reject my null hypothesis. A statistical test is meant to assess the strength of evidence against null hypothesis. So that is what a statistical test does. It will always try to identify if there is any evidence against the hypothesis that we have. What is the hypothesis that we have? Null hypothesis. Here we will not work hard, or we will not focus on validating the new statement that someone said. What we will do is we will try hard to reject the existing belief. So what happens if the old belief gets rejected, then the new belief or the new proposal or the new assumption or the new output out of the experiment gets automatically approved. That is the idea here. Theoretically, what happens when we fail to reject null hypothesis? We never say we accept null hypothesis, we can only say fail to reject. Yes, exactly. So because null hypothesis is the already accepted fact, already existing belief, so we cannot accept the already existing one. So what we will say is we failed to reject the existing belief. Failing to reject null hypothesis means there is not enough evidence within the data and within the test to justify rejecting null hypothesis. So we retain the null hypothesis knowing we have not proven it true beyond all doubt. Now, in the previous example that I've given, what if someone is going to say, no, what is the existing belief? Drinking too much of coffee is injurious to health. Now, someone is going and saying, no, no, this seems to be suspicious. I'm going to conduct experiments and reject the existing belief that too much of coffee drinking is injurious to health. In that case, after conducting experiments, out of the experiments, he still identifies that drinking too much of coffee is injurious. Then what happens is agenda of trying to reject null hypothesis failed. So we will say failed to reject null hypothesis. Rejecting null hypothesis, what happens? This suggests where there is significant evidence within the data and within the test to test justify rejecting null hypothesis. When H naught is rejected, when null hypothesis is rejected, the information is alleged to be statistically significant. We adopt null hypothesis, alternate hypothesis, knowing that we are going to occasionally be wrong. Exactly. So this is a very key point that we need to know. Now we already have an existing belief. A scientist comes up and says, no, no, the belief seems to be suspicious. I'm going to conduct experiment and prove it wrong. However, finally, at a place where during his experiment, he figured out the existing belief is wrong, and he is going to say, yes, as I said in the previous case, the existing belief or the null hypothesis that we have is wrong. Here is my new assumption. Here is my new theory. You should believe this. But this new theory or new assumption or new output or new belief is not going to be 100% accurate, because there are still chances that there will be error in the new occurrence or new output or new belief that we generated. What is the margin of error that one can have inside the new statement? Say for an example, I'm declaring that the bath soap I have found out of an experiment kills 100% of germs in the body. What is the existing belief? What is my null hypothesis? It will not kill 100% germs. That is the existing belief. Lifebuoy and other companies claim that it kills 99.9% of germs in the body. No company claims it kills 100% germs in the body. But however, after conducting several experiments, I have found out a soap, a bath soap, which will kill 100% of germs in the body. Now, this bath soap may kill the 100% of the germs in the body. I'm using that soap to take bath 100 times. Out of 100 times, if 95 times the soap is able to kill 100% of germs, then still the soap is statistically different from the already existing soap. But if the soap is killing only 89 or 80 times, when I'm out of 100 times, if it is killing the germs only 80 times or 85 times, then also we will not consider that as statistically significant. So we want a very high margin of success and very less margin of error. But the conclusion is we will definitely have slightest chances of having errors in the alternate hypothesis as well. So we never accept a null hypothesis. Either we reject or we fail to reject, but never accept. What is the procedure to perform hypothesis? So hypothesis is always calculated by each and every step. The first thing is state the null and alternate hypothesis. So what I'll do is I'll take a data set. Let's do step by step and then evaluate, for which we need a use case. I will say, um, let's take, school example. Now the belief, or let's take the data set. Let's take a belief and then we'll create data set later. Now the idea is the null hypothesis is denoted by H naught HO, H0 basically, which is H naught. Okay, what is the null hypothesis? The null hypothesis says, let's give the same thing here. The null hypothesis says students from both the sections equally. But what is the alternate hypothesis says? Cool. So this is the hypothesis that we are going to test. What is the existing belief? The existing belief is that the teachers and the principal believes that students from, or maybe the teachers are believing the fact that students coming from both the classes, both the sections are actually performing equally. That is what the the teacher is believing. Whereas the principal is saying, no, no, looks like not both the students are performing equally. Looks like there is some difference between section A and section B, are different sections that we have. So this is what the null and alternate hypothesis that we have. So what we will try to do, we know we will try to reject the null hypothesis. This is the idea. This is what we will try to do, reject the null hypothesis. Let's see how does it work. Okay, this is what we will try to do. Once we reject the null hypothesis, automatically we will accept the alternate hypothesis. This is alternate, this is null hypothesis. Let's see what is the next step. State the level of significance. So level of significance is basically a test which lets us perform which it's not a test, sorry, it is basically a metric which will decide what is the margin of error that we can have. So let me quickly give an example for level of significance, which is also called as alpha levels. Now this is basically a metric which will say what is the chances or probability that my alternate hypothesis will fail, or null hypothesis being true. Now it might look very theoretical. The simplest understanding is margin of error. So level of significance is simply nothing but the margin of error. When we learnt about the theoretical understanding of hypothesis, we'll also learnt that the new statement or the assumption will still have, there are good chances of having errors. So what is the margin of error that you can allow, or you wanted to allow? So basically there are three different ranges that we can allow. 1% error in the prediction, 5% error in the assumption, and 10% error. The optimal or the ideal error value that we can allow is 5%. So what happens when I choose 5% as my margin of error is, it gives my confidence interval. Confidence interval is how confident are you in terms of the output that you are generating. So it is 1 minus this. So basically, confidence interval is simply nothing but a metric which tells you how confident are you about the about rejecting the null hypothesis. Are you 95% confident about it? Are you 99% confident about it? Are you 90% confident about it? The optimal confidence interval is 95. Hence, our margin of error is 5%. So it says that if I conduct this experiment 100 times, 95 times I should have evidence to reject null hypothesis. That is the idea here. So let's see how does it actually work. In this case, as I said, the ideal value is 5%. So I'll simply choose the next step is alpha level. It is going to be 0.05, which is basically 5%. We have chosen this. Let's go on to the next procedure. Let us decide a test statistics, z test, t test, or f test. It's a good question. Before we decide to that, we decide on the test, we'll have to first see the data. Based on the data only, we can decide what is the test that we can have. Now we do not have any data here, so what I'll do is I'll create a data set in the next sheet. Um, Class 10. This is section A. I'm just trying to keep it in a format. Perfect. We have section A and section B. We are going to have marks for each and every section. For say, I think we have data for 10 instances. So let's keep this and calculate the values randomly. It will be between 45 and 100. Perfect. Now we have marks from two different sections of section from class 10. What is the null hypothesis? Students from both the sections are performing equally. The teacher is saying, principal sir, both the sections looks like performing better. But principal is saying, no, no, there is some difference between section A and section B. I'm not sure whether section A is performing better than section B or section B is performing better than section A. But I am sure there is a difference. So what we will do is we will try to reject the teacher's belief, which is students from both the sections are performing equally. In this case, we have two sections, which are basically two groups. So whenever you have two groups, okay, and you wanted to compare the mean of two groups and generate an output comparing two groups, I would say comparing mean value of, whenever we wanted to compare the mean value of both these groups, two groups, there are two types of tests that we can perform, z test and the t test. Both the cases, it will compare the mean value of both the groups and tell you whether these groups are statistically significant or not. When I say significant, difference, whether they are differing from each other or not. Just by seeing the value as a human being, you think you will be able to say it. Let me calculate the average of section A and average section B. Looks like the average of section A is better than section B, but this is not enough for us to quantify or give a statement that section A is performing better than section B, because the difference is very less. But again, I cannot tell if it is less or small unless or until I statistically quantify it. With the help of z-test and t-test, we can compare mean of two groups and tell whether they are statistically significant or not. Now you can ask me, when will I use z-test? When will I use a t-test? Z-test and t-test are used even though they perform a very similar operation, but the application, when should I use what, is something that we need to know. If the sample size of the data is greater than 30, I'll simply go with z-test. If the sample size is less than 30, then I'll go with the t-test. In this case, it is very clear. My sample size is only 11. I have 11 students here, so it should be a t-test. Only difference between t-test and z-test is that you will have to make sure that the sample values are calculated and accordingly you perform a test. In this case, our sample is less than 30, so we'll perform a t-test. This is identified. Let's write it here. Um, I'll simply write step 1. Step 2 was not this. Okay, just keeping things right so it will be easy for us to compare between elements. Perfect. Okay, we have calculated what is my alpha level. The third step is identifying what types of tests. So in this case, we have identified it to be t-test. Yeah. Let's see what is the next step. The next step is calculate the value of test statistics. So what do I mean by test statistics? So I said it is a t-test. I also said there are several other types of test also. F test and things. F test is something when we have more than two groups. Whenever we wanted to compare more than two groups, then we'll go with F test. I'll simply write it here. More than two groups. So whenever we have more than two groups to be compared, assume I have section C also here, then in that case Z test and T test will not work, whereas I'll use F test to compare the mean between several groups. Now in this case I have as calculated, I have identified it to be T test. Each and every test in hypothesis, the hypothesis is calculated by a formula. We don't have to know the formula because in every tool we are just going to use the function directly to generate the statistics. So that formula will generate a value which is called as test statistics. So if I'm performing Z test, it will give me Z statistics. If I'm performing T test, I'll give me T statistics. If I'm performing an F test, it will give me F statistics. So that is what they are asking us to calculate now. To calculate T statistics, what I'll do is I'll select the data, go to the data pane, choose data analysis. Let's see where is t-test. See here, paired two sample for means. So it is a two sample uh, test that I'm going to go. It's a t-test. What is my variable one range? This is my variable one range, section A. And what is my variable range 2? This is my section B. And then hypothesis mean difference. I do not have any hypothesis mean difference. So I'll do a different test this time. Okay, let's do the same test, section A. I'm not going to give any difference, so I'm going to just give nothing, and it has labels in it. The alpha level is basically 0.05, which is specified, and then the output ranges, I'm going to keep it here. I'll just take only the T statistics. See here, it has given me a value called T statistics. So let's take this value and paste it here. It is step 4. Okay. This is my test statistics. We have calculated this with the help of a function. Then what is the next thing? Calculate the p-value at given significance level from the table. So p-value is also something that comes by that comes when we perform this statistics. P-value is basically the probability value. So p-value for one tail test is this. P-value for two tail test is this. I'll just copy these both of them and paste it here. Okay. I'll just this is for one tail test, so we will have one tail belief and two tail belief. So what I can do is I'll just okay, we have values for one tail test and two tail test. I'll explain what is a p value first. I'll explain what is one tail test and two tail test also. P value is simply nothing but the probability value. What do I mean by probability value? It will say the chances of null hypothesis being true. uh, that's it. So basically when we are trying to have this statistics value calculated, we will also ask the machine to calculate the p value. What is the least chances, what is the least chance that my null hypothesis can be present in the new alternate statement. So what a machine does is it will calculate the p value out of it. This p value will give us an information which will tell me whether my null hypothesis will be present in the alternate hypothesis or not, and how much it will be present. The ideal value that we will consider for p value is it should be less than 0.05. Why do I say this? Because what is our alpha level? Alpha level is 5%. So p value speaks about the chances of error that can be present in the data set. So if the chances of error present in the in the assumption is less than 0.05, then we have good confidence interval, which is 95% and above. That is why we will keep p value. We will consider, or we will see what is the p value. In this case, p value is for one tail test, this is 0.16. For two tail test, this is 0.322. What is one tail test and what is a two tail test? Let me explain this. I'll draw a line. I'm just going to have data points in it. Now there will be a mean value for this particular data set as well. After calculating mean value, I am assuming this is where my mean value is present. Okay, this is the distribution. My mean value is in the center. Looks like there are more data points in the right side, which is upper side of the distribution, than the left side of the distribution, which is the lower side. This is basically left of the distribution, this is the right of the distribution. So what happens with two tail test or one tail test is, if I know my null hypothesis, what are the chances of having null hypothesis, sorry, alternate hypothesis? I'll choose a color. Now, null hypothesis will be only few things. It will say there are no differences, which is denoted by mean 1 is equal to mean 2. Mean value of both the groups are same. That is all null hypothesis can say. But what can an alternate hypothesis say? There are three different possibilities to reject null hypothesis, right? The first one is there are differences between mean. How do I mention this? Mean 1 is not equal to mean 2. This is one type of rejecting null hypothesis. What is the other way of rejecting the null hypothesis? Mean 1 is greater than mean 2, right? So I'll say mean 1 is greater than mean 2. This is another way of rejecting the null hypothesis. Then the final way is mean 1 is lesser than mean 2. So here another possible way of rejecting null hypothesis is that mean 1 is less than mean 2. In all these statements, it actually contradicts with our null hypothesis. What does null hypothesis say? It says Gautam and Kumar are same, but alternate hypothesis says no, Gautam and Kumar cannot be the same. It says it does not know whether Gautam and Kumar is same, but it is very sure that Gautam and Kumar are not same. This is one way where we can reject null hypothesis. The second way is it will say Gautam is greater than Kumar. Then in that case also the existing belief disapproves. Then the third case, no, Gautam is lesser than Kumar. We cannot have greater than equal to or less than equal to, because equal to will support null hypothesis. So we will not use that. So there are three different chances of performing alternate hypothesis. There are differences. There are the one group mean value is greater than another group mean value. One group mean value is lesser than the another group mean value. Now, right tail test or left tail test, one tail test or two tail test varies by the type of varies by the type of a second. Yeah, varies by the type of test that we are going to do. Now, what is our alternate hypothesis? The principal said the students from both the sections are not equal to each other. The principal is not sure whether section A is greater than section B or the other way around. He simply says both of them are not equal to each other. So in that case, what hypothesis testing will do is it will validate the numbers from it will actually validate the statement from the left side of the mean as well as from the right side of the mean. In both the directions, the machine will conduct hypothesis testing to see if section A is less than section B or section A is greater than section B. Both the use cases it will check. However, if you check in this case, both the sides are evaluated, both the conditions are evaluated, then it becomes uh, a two-tailed test, because in both the directions we are going to evaluate whether evaluate two different conditions, then it becomes two-tailed test. Talking about one-tailed test is a concept where we will know what is actually the condition. We know whether mean 1 is greater than mean 2 or mean 1 is smaller than mean 2. We know this before only. If the principal said section A is performing greater than section B, then there is no point of um, yeah, then there is no point of conducting the experiment in the lower side. The machine will consider only the values that are above the mean value. So it will consider the perform the test only in one direction. If it performs right side to the mean value, I'll write the directions so you will be able to understand this better. So from the upper side of the mean, it becomes the right side of the distribution. From the lower side of the mean value, it becomes left side. Now, whenever we are performing tests at only one direction, it becomes one-tailed test. Here in this case, yellow is one-tailed test. Even if the mean is going to evaluate only in the left side, that is also one-tailed test only. But the idea is, if it is performing the right side, it becomes a right-tiled test. Whereas if it performs in the bottom, it is also a one-tailed test only, but it is left-tailed test. This is the concept of one-tail test and two-tail test, left-tail test and right-tail test. So we can understand the type of test that we are doing. Why should we understand the type of test that we are doing is because for each and every test there is a different formula which will generate the test statistics for us. Now let's close this. Back to this case. So since we do not know what exactly the principal is saying, the principal is not sure whether section A is greater than section B or section A is less than section A. In this case, we will not consider one tail test. We will simply keep two tail test as value. What is the two tail test? It says the value was 0.322. This is my test statistics value. I'll write it here. P value. Now let's go to the deck and see what is the next step. The next step is compare the p-value with the given value. If the p-value is greater than the calculated value, then we will accept the null hypothesis. What we are saying here? If the p-value is greater than the calculated value, let's see what is the p-value. P-value is this. Let's see if p-value is greater or lesser. I'll simply say if this value is greater than this, then tell me greater, tell me it says lesser. My p value is actually lesser than the calculated value. So what does it say? If it is less than the calculated value, reject the null hypothesis. It says the final step is if this is greater, then we will accept null hypothesis. When I say accept null hypothesis, it is basically failed to various. In other cases, reject null hypothesis. What does it say? Yeah, it says reject null hypothesis. So the understanding here is very simple. It simply asks you to reject the null hypothesis since the value of p value is less than the calculated test statistics value. So we will be able to go ahead and reject. What is the null hypothesis? The null hypothesis is, we have written it somewhere. Yeah, we will reject this. I'll just keep it in red, so it means it is rejected. It is rejected. We will go with this particular understanding. What is the understanding of alternate hypothesis? That students from both the sections are actually performing different from each other, even though the difference is slighter. Only 7 is the average value that differs from each and every section, but it says yes, there is some difference between section A and section B. One thing that we need to keep in mind is that hypothesis testing will not tell you what group is different from what other group. It will simply tell whether there is statistical significance or not. If we have to identify what group is different from another group, we will simply perform an ad hoc testing to understand the same what group is different from what. But here hypothesis testing is all about telling us whether a particular group is different from another group or not, true or false. If I say reject null hypothesis, it means the groups are different from each other. That is the procedure to perform hypothesis. Now talking about z-test, the population in z-test should be normal and infinite. It can have huge amount of data. It can be dealt with whenever you have a sample of larger size or smaller size. Smaller size as in anything less than 30 will belong to t-test. Anything greater than 30 will belong to z-test. Alternate hypothesis can be single-sided or two-sided also. It can perform both one-tail and a two-tail test. Talking about t-test, it is a very small data set. The sample size should be very small. and it can also perform both one tail and two tail tests. We're just talking about f test whenever we have multiple means. When I have three different groups, and if I have to three or more than two, if I have to compare the mean value between them, how can I calculate them? I can use the f test to calculate the same. Let me show you a small example for f test, and let's move on to the next one. I'll simply copy this. I'll create a new section called section B. I'll generate the marks randomly now. Okay, we have three groups. Now z-test or t-test does not work. We'll have to take the help of f-test. So I'll go to data pane. In that, I'll choose data analysis. I'll ask two sample for variance, but we are not going to perform two sample. So we will simply go with ANOVA. ANOVA is a product of f-test. Asking me the input range, I've given this. These are grouped by columns, yes, and labels are there in the first row, the column headers, and the output range will be in the same Excel, which has given us values. See here, it has given me f statistic value and f critical value, and it has also given me a p value. So if in this case, what I can understand is the p value is actually lesser than the f calculated value. Hence, it means that we can go ahead and reject the null hypothesis. What is our null hypothesis here? All the sections are scoring equal marks. That is what null hypothesis says. Various alternate hypothesis says, nope, not all the sections are studying well. Now let's see the summary of the information. Section A, what is the average? 79. What is the section C's average? 69. What is section B's average? 72. Clearly there is a difference between average here, and hence here also our p-value rejects our f statistics, which will tell us that the null hypothesis is false. We will reject it and then believe that no, not all the sections are performing equally. There are some differences between each and every section. The same thing can be applied whenever we are dealing with data sets as well. So it does not really matter whether it is a small or a large data set. Whenever you have more than two groups in the data set, you can always take the help of f-test to calculate the statistical significance between them. Okay, let's talk about type 1 and type 2 errors. In the meanwhile, I'll open my Python notebook so I can show you how can you actually do it in Python as well. There are two types of errors that can happen. Let me show you a new sheet itself. Actually, okay, I'll write it here. Type 1 and type 2. These two errors are very important to understand because there are good chances our hypothesis testing will have any one of this error. Building a model without any error is the ideal approach, but let's understand what is type 1 error. Rejecting null hypothesis, I'll simply denote as H naught when it is true. Here it is accepting null hypothesis when it is false. This is what type 2 and type 1 error does. Now you can ask me what is the difference. Now say for an example, I'm saying the soap that I've conducted that I've identified will kill 100% of germs in the body. It kills 100% of germs in the body is what I'm saying. But I did not conduct this experiment properly. Some or the other way, by mistake, I have proved this also. By mistake, I have proved this as well. So what happens is there might be side effects in this. Even though it is an experiment that I've conducted and I have to change the existing belief by mistake. If I approved this, what happens is this becomes a disaster, because having type 1 error is the worst thing that we can imagine of. Because what happens when you have conducted a wrong experiment, the wrong output will definitely impact lives. So they are already people are already happy by using Lifebuoy and other soaps, which actually kills 99.9% of germs. Just because we accidentally claimed our soap to be 100% killing germs without without performing the tests properly, what happens is people will start buying our soaps, and it will actually cause a lot of disaster in the form of side effects, in the form of reviews. We might lose our product brand once people start realizing that this soap is not worthy, and it causes a lot of collapses when we actually disprove the existing belief by mistake. Rejecting the null hypothesis when it is true is the worst thing that we can ever think of doing. Whereas type 2 error is not very dangerous. You are conducting an experiment, the output of your experiment might be valid, but some or the other way you will not be able to prove it. In that case, even though we cannot upgrade ourselves, we will not downgrade. So what we will simply do is we will simply not believe in the existing believe in the newly proposed assumption. We will go with the existing one where the life is already smooth and easy. So this type of error may not cause a lot of damage, whereas this causes a huge amount of damage to the business. If you are applying hypothesis to testing to the business, this actually causes a lot of damage, whereas type 2 error is not as impactful as it can be as type 1 error. Theoretically, here summary of type 1 and type 2 errors. When null hypothesis is true, do not reject null hypothesis. Whereas when you're that is the correct decision. When a null hypothesis is true, if you are not rejecting it, that is the right thing. But when the null hypothesis is true, if you reject the null hypothesis, that becomes your type 1 error. Whereas when your alternate hypothesis is true, do not reject null hypothesis. Even though your new output is true and valid, if you are by mistake you are not able to prove it, and you are not going to reject null hypothesis, that is type 2 error. Whereas when your alternate hypothesis is true and you reject the null hypothesis, that is the correct decision. Type 1 error is denoted by alpha, type 2 error is denoted by beta. That brings us to the end of the class, but let me walk you through how can we implement the same logic in Python. Yeah, all tests are performed here. T-test, Z-test, and F-test also, including ANOVA, is performed in this case. Let me show you them fastly. So I'm importing data from a file called ages. Before that, I'm importing my required packages. Once it is there, what I'm going to do is I'm going to perform a one sample t-test. Basically, one tile t-test is what I'm going to do. I'm calculating the mean value. Just loading. Let's wait for a little. Perfect. The rate is right. This is the mean value of ages, and I'm performing one tail t-test, which will give me the p-value. What is the p-value? Less than 0.05. So what we will say, if my p-value is less than 0.05, we will reject null hypothesis. So in this case, the proof is there is difference between ages in the data set. Then two sample t-test. I'm importing two data set. week 1 and week 2 data. Then I'm calculating the mean value of both the weeks, calculating the standard deviation of both the weeks, then performing t-test, and then seeing what is the p-value. The p-value, I did not execute something, I believe. Yeah, I did not execute this. The p-value is actually greater than the alpha level, which is 0.05. Hence, in this case, we will not be able to reject null hypothesis. We will say we will accept the null hypothesis. Different types of t-test again, and then we were able to perform z-test. If you see here, we are performing a z-test, which will give us what is the value. I will not read the file. So if I read the file, it will not throw any error now. It will give me what is the p-value. Again, if the p-value is greater than 0.05, we will accept the null hypothesis. Same thing can be performed by ANOVA as well. So I'm reading different data sets for performing ANOVA, which is a product of F-test. It says reject null hypothesis. It is as simple as it can be. One way ANOVA and two way ANOVA also we can do using Python. We saw this in the last class, so I'm just not going to explain this again. So using different types of statistical testing, what you can simply do is you will be able to validate the statement which will be quantifiable in nature. The most important thing about hypothesis testing is it should be quantifiable. You cannot say anything that cannot be quantified. I'll not say um, in the future we will be traveling to Mars. How can I quantify it? There is no data to quantify it. So we need to have some statement that helps us quantify the quantify the statements with data present. That brings us to the end of this class. Let me quickly recap what we have learned. We learned about hypothesis testing. We learned about z-test, t-test, and f-test as well. And we learned about the type of errors that can possibly occur when we are performing hypothesis testing. Z-test and t-test are used to compare mean value of two groups, whereas f-test is used to compare the mean value of more than two groups. In type 1 and type 2 error, if you reject the null hypothesis when it is actually true, then it becomes type 1 error, whereas type 2 error is all about accepting null hypothesis even though it is false. Thank you so much for joining this class. Don't forget to like, share, and subscribe to this channel, OdinSchool. Thank you one more time.